Okay, we are going to, well, first I'm going to do this, and hopefully I'm going to make a better XY chart than I was doing in the last one. Okay, so we are going to graph this, and like anything else, we can graph it with an XY chart, and that's what we're going to do. I'm also going to show you how to use Desmos to graph this, and there's nothing wrong with using that. In fact, you should be practicing using the technology as much as doing it by hand, but doing by hand is actually going to involve your calculator as much as anything, and it's an important thing. So we're going to make an XY chart here. And because this is a nonlinear, I'm going to choose to do 5 points. So I'm going to do -2, -1, 0, 1, and 2. Okay. And actually, I'm going to immediately run into problems with what I just read. And I'm going to erase these. If you remember, and I'm going to come back here, and you can tell me what I did wrong. And you can believe I did it wrong on purpose, but that's okay. What's this? The domain is all positive x values. I can't have a negative. So we're going to do, and we're going to do 1, come here, do 1, 2, 3, 4, and 5. So then as I put these in, this is going to be log 5, log 10, log 15. I'm just doing 5 times whatever right here, log 20, and log 25. Then I'm going to use my calculator. There's one I can do in my head, but the rest we're going to use our calculator for. So I'm going to come here and log, because I don't have, so on this there's no B down here, right? So we assume a 10, and on your calculator, that's all it can do. The TIs will do different log base, but most of the basic scientific calculators will only do log base 10. It's the reason you'll see change of base formulas on some of the stuff. We're not going to worry too much about that, but that is how you get like something else. Okay, so I would do log based 5, and it's going to give me like 0.7. So this is, well, maybe 0.7. Now, log base 10, you should know this is 10. 10 to the what? This should be 1. I should be able to do this in my head, but I'm going to do it just to show you. Yep, see, 1. Okay, and then I'm going to come down and I'm going to do log base 15, and I'm going to do log base, what did I say, 20. So I have 1.2 and 1.3. You're seeing these are not growing very fast. That is typical. Remember that I did write that on the thing. This is 2 and 1.3. And this is not going to be very much different either, 25. If you wanted to see it change, this is just 1.4. You would probably need to get bigger numbers, but that's not what we're doing right here, so I'm not too worried about that. Then what I would do is I would simply plot these. So I can see here that 1, 2, 3, 4, 5, and we're going to put that 1 because I'm not going very far, so I'm going to do that. So I can see here, so this is 1 and this is 2. So this is 1 is 0.7. This one's on here. Then you can see here. Now, this is coming down. If you wanted to see this, and this is where probably might want to throw another point here, like, oh, all of these are going to look like this in general. But if you didn't remember that and you weren't sure what it was doing here, because remember I wrote on here, and this was on the list here, there's an asymptote right here. It can't go past this. Put in 1/2. I don't know what I just did here. This is 5. So I'm going to put in 1/2, and I'm going to do log base of 5.5, right? So if I come back here, log base, it's 2.5 is 5.5. And that's my 0.3. So if I came here to 1/2, I'm going to be down here and going as I get smaller and smaller, I would. So let's see here. Let's do log based. Let's see, I have a 5, and I'm going to times it by, what do I want to times it by? Let's do 0.1. I get a nice small number. And now you can see, now I'm getting the negative 0.3, so I'm coming down. So just kind of a sense of what you're doing. You can always throw more points at it. If you're not sure what it's doing, always throw more points at it. And I'm kind of building this so you can kind of see how you're going to build this. I didn't really go in with a huge plan because you're not going to. I already know what this looks like. You aren't necessarily going to, and that's okay. So you're going to want to throw more points at it. You're going to want to kind of explore, do it. But then you can always come back to this list I made to help you make some decisions. Now, what about Desmos? So I got too many screens here. Come here. Okay, I'm going to come over here. I'm going to go to Desmos. And I can come here and I can put in y equals log base, in my case, 5 of x. And I can see right there, there's that 0.2 that I would get if I go up. But if I can come right there, if I'm really careful, there's that 2, 1 that we would expect. So if we come back here, there's my 2, 1, there's that point. And I can come out and find the other ones. So if I went here, that's 4, and I can see there's my 1.3. And you can see it's going out very slowly. And it's never going to get, if you look, you see 0, it's undefined. These, I would have to go, if I expand it, you can see here all these little points. By the way, I just used my fingers, but you can come up here. There's a wrench over here. And you can always change this if you want to expand this out to see more what's happening down here if you're not sure and you want to explore. This is a great way to just kind of explore and see what the function does and how it works. This will also let you, if you come in here and you go to functions and you come down here to the bottom somewhere, right there, log based A. So if I do this, this will let me put in, say, like 3x. And so then that would give me that one to compare here. So if I did want a different base, it will let you do this here in Desmos. So hopefully this gives you some thoughts and how to work this and just kind of explore with these graphs.